So in this video, I'm going to go over the two quizzes from this unit. First one is the 2122 quiz. We're going to start with number 1. A triangle in the coordinate plane has coordinates of 3, 5, 1, -3, and -3, 4. It's translated so that its new coordinates are 1, 7, -1, -1, and -5, 6. What translation occurred? I want you guys to first notice this word right here, translation. That tells me that I should be able to add or subtract from these numbers to get my new number. So I got 3, 5 that I started with here, and it changed to 1, 7. So we want to talk about what had to happen here for us to do that. So to go from 3 to 1, we would have subtracted 2. And to go from 5 to 7, we would have added 2. So what would the translation have been? Then we would have went, if we put this in a vector, it would have been -2, 2. And that vector also would then talk to us about left or right, up or down. So that the first two positions would be 2 to the left, and then the other two would be 2 up. And that's because the first position has to do with our x value and the second position has to do with our y value. Number 2 says, which triangle, when translated 12 units down and 7 units right, will result in rectangle E? Here again, we got that word translated. Important because I know that it wasn't rotated. That means I can eliminate A and C because it wasn't rotated. So then we're just looking at B and D, and we're trying to figure out which one of them was translated 12 units down and 7 units right. Well, I can tell by counting 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12. Well, they were both translated down by 12. So then we want to talk about which one was translated by 7. So let's just go with this D one first because it's closer. So I'm going to count 1, 2, 3, 4, 5, 6, and 7. Yep, and that's the same as here. So it is D. It was translated, so it's this one right here. And B would have been by 11 because it's 4 to the left. So to get B, we would have then 11 to the right and 12 down, whereas D is 7 to the right and 12 down. So our answer again was D. So number 3 says a triangle with the vertices of P, -5, 6, Q, -2, 1, and R, -3, -3 is reflected across the y-axis. State the rule for the reflection. Identify the coordinates of the image for point Q. So it says here it's reflected across the y-axis. So the rule for that is x, y becomes, and if it's reflection over the y, the x changes. So we're going to change the sign of the x. And then we're going to do that to point Q. So our original Q was -2, 1. So when we apply this rule, -xy, to that, is going to make it now Q prime is going to be +2, 1, because we just changed the sign of the x value. Number 4 says a figure has the vertices of 5, 5 for K, L, 5, 3, M, 1, 1, and N, 3, 5. After a transformation, the image of the figure has the vertices of -5, -5, -3, -5, -1, -1, and -5, -3. Identify the transformation. So I want you guys to notice that when we look at this image here, we can start mapping these points. And so I want to look at N to N here, and M to M, and K to K, and L to L. This looks like a reflection to me, so I'm thinking it's a reflection over this line right here, which is y is equal to -1. Sure enough, looks that way to me. And does this look like it's congruent with that? Those lines all look parallel, and each of these lines looks like they are being bisected. So this is indeed a reflection. Over the line, y is equal to -x. And the rule for that is x comma y would become -y comma -x. And that's exactly what happened. They flipped and they became both negative. Finally, number 5 says a triangle has the vertices of A 2, negative 2, 3, B 2, 1, and C 1, 0. After transformation, the image of the triangle has the vertices of A prime, negative 2, negative 3, B prime 2, negative 1, and C prime 1, 0. Identify the transformation. So we're going to compare A to A prime. So we got A here is negative 2, 3, and we've got A prime is negative 2, negative 3. So let's see if we can come up with a rule here. Well, I notice that the x doesn't change at all, but the y does change sign. So this is the rule, and we should all know that that rule means that this is a reflection over the x-axis. Remember, we should reflect over the x-axis. We change the y, the sign of the y. Now I'm going to go over the 2, 3, 2, 4 quiz. On this one, it says, describe the transformation that maps the preimage A to preimage A prime. So the one thing that I noticed first is that the image shifted to the right. So let's count how many. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wait, I missed my count there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 10 to the right. Now, if I draw that image over here, whoops, wasn't a very straight line. I don't know what happened there. If I draw that image right here, I guess there's a bump there or something, y'all. It's not liking that. Then I also notice that this is a reflection. So it went 10 right, and if I notice here, it went 1, 2, 3 over the x-axis, 1, 2, 3. So it went 10 right, and then it reflected over the x-axis. Number 2, let me go ahead and scroll up a second. So with number 2, it says the figure is transformed as shown in the diagram. Describe the transformation. So I noticed that if I look at this top part of the T here, it goes from being horizontal to being vertical. So I think that that's a rotation from 1 to 2. And then if I go from this point right here over to this point right here, we just move to the right, and that's a translation. So I think it was rotation and then translation. And we would call that a turn and then a slide, right? Okay, so let's talk about number 3. It says identify the rotation rule on the coordinate plane that verifies that triangle ABC and triangle ABC prime are congruent when rotated 180 degrees. So let's look at these points again. We're going to compare A, which is 2, negative 1, to A prime, which is negative 2, 1. So notice here that the points didn't change. The only thing that changed was the sign of the points. So the rule that would result from this would be then negative x, comma, negative y. And again, remember, anytime we have those negatives out front, it basically means that we're changing the sign by using that rule. So number 4 says name the resulting x after reflecting, x double prime after reflecting triangle XYZ across the y-axis and then translating XYZ prime along the vector to 0. Okay, so let's take this point x right here. That is negative 1, 4. And we're going to do the reflection rule, reflection over the x-axis. That would be negative x, over the y-axis, y. So that's going to give us x prime of 1, 4, because we only just changed the sign of the x. Then it says we're going to move it along the vector of 2, 0. So that's going to be x plus 2, comma, y plus 0. So that's going to be our x double prime. So 1 plus 2 is 3. So it's going to give us 3 here, and 4 plus 0 is 4. So that's our final image of x double prime. Sorry, should have been double prime there. Number 5 says, what is the correct coordinates of S prime after rotating triangle RST 90 degrees about the origin? So our S, we got to find that point first. S is 4, 2. Our rule for rotating 90 degrees about the origin is negative y comma x. So we're going to apply that rule to get our S prime. So that means we're going to flip them, and we're going to negate that one. So that is our point. So it's going to be negative 2, 4. Number 6 says triangle KLM with vertices of 2, 1, 4, 3. 4, 1 is reflected across the x-axis. Then its image is reflected across the line y equals x. Identify a single transformation that moves the triangle from its starting point to its final point. Now we only have to use one of these points. So let's use K. So K was 2, 1. And again, we're going to use our rule across the x-axis. That's going to be x comma negative y. That's the rule. So that's going to take us to K prime. So that's going to give us 2, negative 1. Then we're going to do K prime, which was 2, negative 1, and we're going to reflect it across the line y equals x. The rule for that is yx. So then we're going to get our K double prime here. So that's going to be negative 1, 2. Then what we want to do is compare our first point with our last point. So we're going to compare K, which was 2, 1, to K double prime, which is negative 1, 2. And we're going to come up with a rule for that. Now you should immediately notice that the x and the y flipped. So I'm going to say y comma x. Now which one changed signs? I noticed that the y changed signs. So then we have to figure out what is that the rule for. Negative yx is the rule for a 90-degree rotation. Number 7. Point A, negative 2, 2, is rotated 270 degrees clockwise about the point 1, 1. What is A prime? So here, we're going to start with our A, and that's going to be negative 2, 2. If you recall, I said what we're going to do is we're going to subtract the point of rotation from that. So we're going to subtract 1, 1 from that. That's going to give us negative 3, 1. Then we're going to apply the rule. And the rule here for a 270 degrees counterclockwise is y comma negative x. So we're going to apply that rule. So that means we're going to put our y there, and we're going to change the sign of the x. So that's going to give us 1, 3. Then we're going to add back the point that we subtracted. So now we're going to add the 1 and the 1. That's our add. And so our final point is going to be 1 plus 1, which is 2, and 3 plus 1, which is 4. So our answer is 2, 4. So remember the process. We're going to subtract the point of rotation from the point being rotated. We're going to apply the rule, and then we're going to add that point of rotation back to get our final point, which is A prime.